It was terrible. Because I've known you for 3 years, right?
I'm like,
And you're hardly forgettable,
send me the link.
right? You're hardly forgettable. I don't know exactly what that means. It's the curly hair, maybe.
Maybe.
But yeah, I just actually I've forgotten you several times too, Paige.
It's okay. I won't.
The 12 students. That's just overwhelming my memory, which is probably why phone numbers are not.
My largest student
10.
was 18 students.
Oh gosh.
I never had a student.
Okay, so I'm gonna put you on. You're gonna be on now because you're eating. So greetings. I'm gonna get started. Another great night of conversations led by all of you. Tonight's the second night of reviews for our design studio. As you know, accompanying us on, and we look forward to another good night tonight with Lindsay Woods. So Lindsay is an architect and a project manager in our office at Hamilton Anderson. She's also a Clemson Tiger and is happy to be here because she's done the reviews for my studio several times, always in the advanced design studios. I think you did. Did you do the mixed use hybrid studio or just the missing middle?
I did mixed use and missing middle.
So she's had an opportunity to look at the type I've been servicing in the last few years. I'm looking at the screen right now, and it says that the broadcast is occurring, and I apologize that for some reason, after nearly 22 minutes, the broadcast stopped recording on Tuesday night. I don't know what happened. I do know that I actually clicked stop broadcast at the end of the evening. So from my perspective, it looked fine. So I'm frankly distressed that that has happened because if it doesn't happen tonight, then the people that are in this room or in this session have the advantage of being able to look back at their conversations, and you all from Tuesday night won't. So I apologize for that. In any event, we'll need to get started. Lindsay, just for your edification, the studio that we are looking at today is both graduate level and undergraduate level. The graduate level students who are maybe in our 3+ program, a Bachelor of Arts in Architecture or in Environmental Design or Historic Preservation or whatever. They come from another school, perhaps, is the best way to put it. Could you keep it down over there? I'm just kidding. So so they're needing to take this class as a compulsory studio in order to sort of pass muster to do the graduate level work shortly.
So they'll be in their first year of a 3-year program.
That's correct.
Okay. Which ones will we see?
So we don't know. I mean, I know which ones are which, but but like even looking at them right now, I can't really tell which ones are the grad students or the ones that aren't. And this class is offered, as I understand it, in both the fall semester and in the spring semester. But Ash, who I'll introduce you to, assures me that the spring, this is when this core class is expected to be taken for regular students. So these irregular sequence, or maybe they intentionally accelerate their sort of curriculum. So we have 2 sections, graduate, undergraduate, and they comprise, at the end of it all, 12. So what we've done, an intimate experience of a review, 3.5 or 3-hour time period, we've had to, which is what we're going to do on December 8th, and you'll be invited back for that. That's that Flex Friday date. And so those reviews, Lindsay, will run, 5 hours or so, 5.5 hours. And so we'll make it work for them on that date. So Ashraf Ragheb is our lab professor. Ash is a full-time faculty member. Ash, this is Lindsay. Lindsay, this is Ash.
Hi, Lindsay.
And Ash provides kind of the intellectual and tectonic and construction and structural and building enclosure, all the stuff that they need to know for this class. It falls on Ash's shoulders. All of that. I'm kind of just baggage in the studio, and so Ash puts up with me for the rest of the week, and he can tell he can tell.
What is some of your professional and like educational background?
I have Bachelor of Architecture Engineering, Master of Architecture, and PhD of Architecture. I'm a licensed engineer and licensed architect, and Go Blue alumni.
Yeah, he's a big deal. So I think I have to turn my volume off now so that you can speak to the class. And we're going to start with Paige first. So the other gig, as you know, is to basically indicate your sort of assessments, either like on the fly or tonight or tomorrow, and then return them to me, Lindsay. I'll scan them and share them with everyone.
Do you want notes as well, or just
Do both or just one, whatever you want, whatever you're comfortable with.
I'm writing notes?
I know you do.
But I don't know if that's needed or not.
Yeah, that's perfectly fine. And then this benchmark has a series of like issues, structural system, so there's, and each of them have their own sort of value relative to everything else. They had a design that they created for the first benchmark about 1 month ago.
Okay.
And the expectation was that for this benchmark, they designed through the lenses of these new categories. So the work you're going to see tonight, design, and then talks about it within these sort of criteria. And also, just to fast forward, so we can hand the mic over to Paige, the A3 site at Brush Park is the site for this project.
That was going to be my next
And it's
question.
a 55 and older
Senior living.
senior living development. It will have 50 apartments in it, in a mixed-use building with underground parking, and they have to provide 50 spaces on the site.
50 parking spaces on the site?
Yes.
And then what is the unit requirement?
1 bedroom, 2 bedroom, and there's a ratio of those that they have to provide. And
So all the buildings are in Michigan,
they're all the same site.
and they're all the same site.
Yep.
And everyone in here has looked at a code book.
And we had a benchmark early on that talked about a number of issues like sustainability, the building code, the history of Detroit, the history of Brush Park, and on and on and on and on and on. So everyone has the same intelligence and background, had the work that led them to their design.
Okay.
Okay.
All right.
Any other questions? Okay, so let me turn this off. Page up. Oh. For those of you who are presenting tonight, make sure you upload your work to the Google. So are you sharing that work, or we can look at it there? So can you just open that one?
This one?
Yeah. And go to benchmark 2. And then go to pages, which is this one. No.
This one? This one.
Yes.
You said that conceptual designs have been worked out previously, or also in this
Yes,
class?
but
In a separate studio?
no, in this studio, but for the first benchmark. But some of them like to finesse them, or some of them were behind. So,
So we can still address concept.
oh yeah. Whenever you're ready.
Okay. You got. Okay. The first page. Give an echo. Okay. Page is my basement parking. I was able to fit 41 spaces down here. So behind the stair, as you can see, but there's always a between to like have enough room to like back out and everything. I also have some locker storage against the north wall, and the mechanical room also against the north wall. Moving page. This is my ground. On the upper right corner is where my retail is. That corner between both stairways is all retail. And then on each below, the garbage room on the south side, and then another store in the other leg, along with a generator room, and then all the other required like the office space, the gym. On the right, on the laundry space down in the corner. And then I also have 9 spaces to get my 50 total on the ground floor. And then in between, like in the middle of the U shape of the building is like a green area space where there's. Moving to the third page is my typical residential floor. It's identical between floors 3 through 5, except for on the an additional laundry room. So these are all the spaces. I guess the typical room, I guess, would be kind of the corner space, the corner on the north top right, typical. But they're all different. But they are all, the 1-bedroom are between 740 and 720 square foot, and then the 2-bedroom are between 840 and 900. Moving to the next page, it's showing the 6th floor, which have 5 additional 1-bedroom spaces. And then on the west side, next to the stairway and the egress, there's like a covered area. That's where those columns are still. You see it better later in the 3D view in the elevations. So this was just to get the total of 50. I had to add a few more rooms up on top. Next page is showing just that. And then page 6 is the north elevation, where you can see how like the balconies are weaving in and out. So I didn't want like a flat facade, and so like section is like a balcony, so weaving. Those are the other elevations. And then page 10 starting is showing the 3D view, so you can kind of get a better idea of what it's looking like. And also page 11 is the other corner. So page 11, John R. and Alfred. And then page 10 is showing like the alley where the ramp is. And then page 12, I'm starting to show different uses for the spaces. Red is ventilation and egress. Yellow is community space where it's all usable by the whole community. Like purplish is like the mechanical rooms, the ducts, the trash um, trash duct, I guess. I don't know what to call it. So that's just the next. And then you can really see on the retail versus the communities use spaces are. Page 14 is showing the one bedroom and two bedroom. Two bedroom is in green and blue. So that's the typical 3 through 5 floors. Floor 6 is showing the remaining one bedroom spaces. And getting into the HVAC and zoning is page 16. I have it separated in 2 different zones. The ducts tucked next to the L, and then it's showing where the main ducts are going to be.
This is not the retail level, this is, or.
Retail level. And then the next couple are the residential. So 17 is the 3rd floor. And then level 6 is also separated into 2. Page 19, structural plan. The columns and beams and girders. So for the columns, I'm using the 12-inch HSS column because I'm using the Tonex Tech system. And for the use, they suggested the 12-inch HSS system for their company's use. And then I also use the W16 beams and then W18 by 36 for girders. And then I also mentions of how far they're spaced out. And the last page is showing my details. So the first one on the left is the masonry steel structure, showing the floor and also the window and how the wall meets the window. And the 2 on the right, the upper one is the top part of the window or door. It's the same. And then the bottom right is the roof. I'm done. You can go. That's it.
What is your same differ between retail and tenant spaces?
No, it's the same for like the whole building separated.
How do you, so each person has a different level of comfort group? If someone wants to run hot air and someone wants to run, are they allowed to do that, or do they use like the windows open? Their natural ventilation.
I was thinking there'd be like a thermostat. Choose what your comfort level is, or like change it. But I'm not sure with my system. Like, I don't know.
Just initially, and granted, I'm not a mechanical engineer by any means. It looks like you're creating the same temperature level for all of your residents in your retail spaces, which typically you divide it up in some form or fashion. So you may provide larger zones for retail tenants and then individual zones for each resident, and it would be controlled by people. There's several different systems that actually accommodate that, and they have there's different features of them.
Mark, I need, I hear a lot of echoes.
Power pack in the room, and that's which is extremely expensive for the tenant, but really, really cheap for the building owner. And then a larger system would be like a zone system with like maybe a VUV control system. there is a larger system that it runs off of, but each person can still control and monitor and change their own things. So I would recommend showing some different schemes for your retail and for your individuals. I think you have some good ideas about where the supply and returns can start and when they can kind of, get into the building or go to a main core, but I would expect you to kind of talk about how you're heating and cooling some of these different spaces and units in your building. And talk directly about how each person can change their comfort level in the building if they have control over that, or if they don't have control. I mean, there's another thing you can talk about too, like we have the ability, whether it's comfortable or not, or people like it or not, to control that space and what's in it. And so you could intentionally make people uncomfortable if you wanted to with your system as well. So those are some things I would definitely hit on related to the mechanical. Do you think you probably will have some large zones like you're indicating, but I think they'll be more specialized than you're currently showing?
I can't hear very well. Can somebody just turn off a mic or something, or turn on Caitlin's? Somebody can turn on Caitlin's mic. I could not hear anything.
I'll have to talk louder. Can you hear us now, Ash?
Not very clear.
Okay.
Like on Tuesday. I don't know what's going on.
You still have the floor. So you have to turn it off now. Your volume. Yeah. I think we're okay.
Someone else is
Okay.
Okay.
Some other things, just generally, again, the impact of this. I think it would be advantageous to show the same kind of color and programming elements that you're showing on that second kind of set of drawings. I think you can talk about the programming elements, circular spaces at the same time that you're going through the floor plan initially. So I don't think that they really should be like a separate diagram. Okay. I think there's also some good opportunities to talk community spaces, that green space where your parking is, how that sidewalk, like an at-grade balcony level can bring from the area around you. A site plan would be nice to see some context is, and where do people come from some of the public facilities at your site. Some color in your elevations would help. I think you talked a lot about this weaving effect and how there's different odds on your elevation, but it was really hard to see it in the way that it's diagrammed currently. So some colors, some implication of like shadows or where they may be, even if you're kind of initially, will help us understand more clearly that you're trying to have that in your project. It's there, it needs another layer. The other thing is I think that if your plan meets your program requirements, you talked about your parking spaces and where you provide. I think some of the parking spaces are still a little bit tight and people are looking in some of them, but there's always kind of like some awkward spaces. Like I would probably change your 12, 13, 14 down to 2 spaces, but I do see you have a column in the way. Maybe you go down to 1 instead of 3 in that area, which kind of creates other problems later, but it's better to have that than to be sued.
Mm-hmm.
And then the other thing, just on the project, you ended up with this really like rooftop area. It needs to have some more details, flat cap, but when you were given your presentation, I still needed more units, so I put a few more on the roof. As I wanted to break down, but I didn't, we wanted to start seeing some layers. This was a little on the roof. It was already coming here and visiting other people that are in the area, and then developing a little bit more on what that roof component is, because in a building like this, you have spaces to gather, and so that roof component really offers. Talk about if you're doing heating systems there, so that like people can go up there and use it. I would also talk a little bit more about we're addressing ADA code issues as well. So one thing that I noticed that's interesting on the roof, and we didn't talk about any calculations or load types or size, but you're showing 2 double doors exiting your roof. One door going towards 2 stairways to exit. Usually you go from smaller to larger to smaller.
Okay.
So you may just want to check up a little bit of occupancy and egress requirements. Also want to limit how many people can be on your roof terrace based on some of the requirements for, you have and railing height so people don't fall off the roof, or maybe you don't get too close to exiting the roof. You may make your roof terrace a certain size because it's too costly to do it a different way. And it's an assembly space, so people, probably more people than you have in this other places in your building. So you want to see if you want to pay to have that many people up there.
Okay.
Ash, do you have any comments?
Okay. Do you hear me? Do you guys hear me well? I cannot hear anything. It's just I don't know. I cannot like sustain this kind of interruption because I know I need to hear every word so that I don't repeat things here. Anyway, I'm just gonna do a screen share here, very quick page, and I'm gonna go very fast. I don't usually comment on the design and the bosses here, but in the basement floor plan, spot 11 and 14 will not work, so you are losing 4 spots actually, 11, 14, 17, and 21. You cannot have the car backing up in here, so these 4 are not functional. I think there is a door here missing somehow to reach to the elevators. I don't know how these people will kind of access the stair and the elevators. Your stairs as well, Paige, don't meet the code. Please double check that you have here at least 44 inches. Your landings are very, very small. I don't think this will achieve the 44 here, both landings. It has to be almost sort of a squarish. Probably I'm wrong or deceived by the scale. The elevators also kind of squished. I'm not sure how, what size they are. Just make sure that you have the minimum size. I think 4.3 by 5.8. That's an ADA. 4 feet 3 inches by 5 feet 8 inches. And I doubt these will fit in here because you have to see it to leave some space around for the rails of the elevators. These are just some very small things, logistics. Elevations, there's still a lot way to do here. You have, again, to have concepts. Simply you have projection of your elevations. Thanks for the 3Ds, but again, we need to see some materiality. We need to see some, you do have probably the positives and negatives here, but again, you need a concept for your elevation, not just a projection from your floor plans. I love your HVAC so much. It began to develop very well. Although again, this doesn't. Oh, this is the retail. Okay, that's fine. But we still would love to have the service ducts on the back, like this one here. This is good. Next step forward, I would love to see you have here the return and the supply. I would love to see the distribution of the supply and return, but I'm okay with this. At least it works. It has your basic understanding of zoning. You have the mechanical room back here, so you can attach the vertical shaft very well. You have an additional mechanical here on the other stair, which that's great now. You had this on the back last time, the duct on the back, which will not work, the vertical shaft. Again, these needs to just an extra to tell us how the air would go to these different units, but that's a later stage. At least you have the basics. You do have some unsafe beams here. This is considered your beam, and I think that's safe, probably the W18 by 36. But this one here, the verticals, since they are girders, these beams are unsafe. The W16 on all of this side, all of the verticals. Well, we have two trends here when we do structural floor plan. If your owner is greedy, you end up having different sizes for different spans. If your owner is okay and you do your job by being a really excellent designer and your bays are kind of close to each other, yes, we can make it one beam like what you did here. But this is unsafe. If you divide 28.6 over 15, this will give you W22, not W16. So please correct that. You are missing here. That's the sections. They are much better page. I love them, but you forgot the drainage space here. Okay, between the brick and you don't have brick here. Oh no, it's stone unit. Okay, even with a stone, you have to have a drainage plane. It's 1 inch by code. However, all the masonry institutes here in Michigan and the United States recommend more than 1 inch, possibly 1.5 or 2 inches. So you don't have a drainage space here. Your parapet needs to cover the you're gonna have a lot of snow accumulation here. So this needs to cover the membrane from here, okay, and go all around to cover the stone. Okay, are you with me?
Yep.
Okay, so this is just again just a very quick comments, but they are way better. At least they show the structure, and above it there is the concrete slab, and I see here the tie plate, very nice. So but again, please put back the drainage space and try to fix this parapet here. Thank you.
Thank you.
Okay, so yeah, I have. Can you hear me now?
Yes, but yes and no.
I just want to be the a stone veneer building. Is that really what you're intending? It's not something that we maybe talked about in the earlier iterations or the earlier discussions, and the rendering of the building in the necessarily talk about that. It doesn't really talk about that in the elevations.
Yeah.
So
It looks more like a metal panel construction.
right. So I guess I'd say that, like like there's like doors missing in the stairwells, in those lobbies for the stairwells, and the wells aren't really sized correctly. Those little things indicating some other little things in like, I think you need to add to the drawings. And if this is a stone building, then there's going to be a whole sort of campaign of mortar and control joints and maybe expansion joints. So as you move into the next stage of drawings, these elevations need to describe that. The elevations are actually, they're fairly generic in the sense that they kind of specific information. Also, the balusters and the guardrails at the balconies should define what they are made of, and that's kind of what they might look like.
Mhm.
But maybe if you cut a complete wall section, not these little enlarged section details, but like an entire wall section
Thank you, Mark.
through the building, right? Then you'd see the opportunities to detail more, and you'd show of what's happening in this building. I also think that the column lines that you have building itself need to evidence themselves. So you
Okay.
translate that grid
Mhm.
from the two sort of three-dimensional. If you
Can I make a couple more comments?
yeah, go ahead.
So,
But make sure he hears it.
so the other thing too is you're probably gonna have some different window types on your ground level and to your residence. Right now, they all kind of look like these in place cased windows and front language or grand opening on the bottom. I want some indication that maybe some of them open, maybe some of them don't. And I think they'll start to be a different, like, conditions will evolve in another level. Like, especially once you start choosing the railing type, you start showing some indication of, you know, transitions. If it is a stone, then you like additional line work to show the stone type and size. And then again, you'll end up with some sealant joints. And so happens right at the column lines, maybe it doesn't. Another layer too, didn't look into it too much. You have some regularity with lines, but it's almost like you started out with one size on this building, we consistently showed two bays on the other side with the same dimension, but maybe it makes more sense to have two of the same and then two of the same that were on the left or the right, or
Right.
something like that, because you kind of go, you have like a, where's the one that has the dimensions on it? Structural diagram.
Yes, later.
But again, that's going to speak to your elevation because you're changing
Right.
your elevation type when you're changing. It's like I can tell you're starting to design with the column, your floor plan, and that's going to again talk to your elevation. So yeah.
Yeah,
Those are
26,
times
26, 26.
And then,
Down to 24, and it goes back to 20.
and then on this side, it's 21, less than 21, and then up to that 28 again. I'd rather see like,
Yeah, and I'm not sure that these column bays actually will rely on the elevation, right? I think that's what I'm hearing.
yeah, they wouldn't. I mean, ones are more prominent. In that case, it is going to heavily affect your, and you're going to see that. And so, do they become like a stronger element in your design? You obviously have your windows in between those columns, so that's probably where we're seeing that inconsistencies on the elevation because you do have that small, like a slightly smaller bay, and then you have a larger bay again. So maybe working with those kind of layouts and lines will help you design your elevation.
Thanks, Paige. Let's
Thank
move
you.
on to
We're ready when you are.
Can you hear me? Not if you can hear me, please.
You're
You
good.
can turn yours off.
Okay.
Okay. Thanks.
My first page is just a title sheet, and you can kind of see City of Detroit there in the background. This is trying to express one of the primary concepts of the building that I'm going to have moving forward. Next sheet is a site plan, or not really site plan, site analysis, really. I'm just showing different traffic in the area, showing the location of Detroit City Modern, and showing the primary axis that I'm basing this wedge of the building around and how it aligns with the kink in John R. that's to the north of the site. Next page, I'm just showing a couple diagrams to indicate why I laid out the building the way I did. First diagram, I'm showing the step back, or the setback from the street. I set my building back even further than the required setback to provide some relief for this heavy trafficked area, and I'd like this to kind of be more like a gathering space for people out there. So I wanted to set the building further from the street. I also made sure to push the building towards the street, if that makes sense, so that I could leave the area open in the lower left for parking and access. The other diagram is just again delineating that primary axis that I'm following with this wedge. Third diagram is indicating the different faces of the building, you know, the primary faces, and then the secondary and the tertiary faces, facades. Below that, there's this continuing diagram that just indicates where I pulled different parts of this block out to create these different spaces and my thought process in that. The next sheet is the first of the floor plans, and here I'm indicating my lower level parking area, and then off to the right you can see, and I hope it's large enough for you, you can see my structural, my mechanical, and my life safety concepts. And I have larger structural plans later, Ash, if that's too difficult to read. We'll get to that at the end of the presentation. So I'm just trying to show here that I'm using these hollow core concrete decks that are supported on these round 24-inch cast in place concrete columns that's sitting on precast concrete beams, 16 by 32. I think based on our conversation, Ash, we decided those were going to be large enough to support the load we had. Below that, for this sheet anyways, I'm showing just conditioned and unconditioned space, because this parking structure is not going to be conditioned at all. Essentially, this whole floor is unconditioned. Below that is the life safety plan. I'm showing some occupant loads, and then this 2-hour fire separation that's required for these stairs. On the next sheet, we start to see the this is the ground level now. We can see the retail spaces on the right-hand side of the site, and then kind of all the support spaces for the residential are up on the northwest corner. You can see the parking ramp that leads down to the lower level there, and the 15 parking spaces we have in the middle of the building. Again, just another structural, mechanical, and life safety plans off to the right side. You can see that I've got 2 separate zones for my mechanical space here. All the residential units are going to be served on Magic Packs, but for these, anything that's not residential will be served on a central AHU air handling unit system. Below that, again, just a life safety plan delineating the different occupants in the spaces and their proposed means of egress to out of the building. Next sheet, a lot of the same as we had before, except for you can see an enlarged unit plan. And I'm trying to show my accessibility requirements. You know, each one of these spaces, wherever we have a door, is somebody in a wheelchair could get out. You know, they've got that, oh, it slips my mind what that's called, but that square That's got to be 60 inches by 60 inches or whatever it is. And then I'm also showing the Magic Pack unit and its location relative to the rest of the space, and some proposed lines that could service these spaces. Off to the right in the mechanical sheet, or the mechanical plan rather, we can see where these two separate zones for this central system are going to be. And then I've got the square footages of those zones highlighted as well. Next sheet, I'm showing a 1-bedroom unit instead of a 2-bedroom unit, which was on the previous sheet. Again, just trying to highlight that and show how that space works. Also on this floor, we transitioned from hollow core concrete to CLT panels, which stands for composite cross-laminated timber. And for the most part, if you want to think of it, this is how I think of it, it's like plywood made from 2x construction. And it's all glued together and forms this panel, and can be used for floors and walls, and is really quite rigid. I'm also using timber columns and timber beams to support the structure. Again, we'll have larger structural plans at the end of the presentation that we can comment on and take a look at. Moving on to the next sheet, I'm showing an affordable unit here instead of a 1-bedroom. Again, pretty similar. We're seeing most of the same stuff. Next sheet, I'm showing, oh, it says affordable unit. That's supposed to say studio. It's funny how you catch those things as you're presenting. So that's a studio unit layout, typical studio unit layout. And I did notice as I was doing my life safety plan here, I'm going to call this out so that's hopefully somebody doesn't beat me up on it too bad. But the exterior terrace on the upper left, or upper right rather, I'm thinking that maybe that cannot be accessible by the general public, because if it is, the path of egress is too long. So it's probably going to have to be a private terrace. Maybe put some fencing up in order to separate it to the individual units. Moving on to the next sheet is just a typical, or is my roof plan. And I'm showing the green roof on the right side of the building. Again, community spaces up here. We have a live or work share space where I would like the residents to go up here and work. Maybe if they can get a Friday off, or they can work from home on a Friday or something, they can go up here and then enjoy the view of downtown while they're sipping their coffee and working on the computer. To the lower left, there's a little diagram to show how these green roofs kind of go together, all the different layers. Just showing that I am conscious of this. And I know what is expected there. There's also a solar array on the left-hand side of the left portion of the building. I recently just had a solar array installed at my house, and so that's where these numbers are kind of coming from. I'm thinking that based on the number of units I have here, I can get 105 kilowatts of solar energy, which should provide enough power for roughly half of the residential units. And the life safety plan, I made sure to indicate that there's a maximum of 49 occupants on this level. Again, I think that's probably something that would have to be discussed with the code official, because I think you had mentioned, Mark, that because this entire roof is a green roof, you'd have to put some type of not requirement, but restriction on the number of occupants in this space. So that would be something that would have to be worked out. If not, then I'll have to do something else. But on the next sheet, we can see some elevations. Here I'm just kind of indicating different material uses. Next sheet, I'll try to speed this up. Again, roughly the same thing, different materials. Next sheet are some building sections where I'm showing this 2-hour fire separation that's required to separate the lower podium from the upper timber construction. Next sheet is just kind of this 3D cut through the building, and I provided this because I wanted to I wanted to make clear the idea that I've got here with the center sloping ramp courtyard area. I think this is really cool, but it was always difficult to show, so I tried to show it here. The next sheet are my enlarged details. Obviously, I pulled the one detail on the left from the internet, but I'm using this to describe some stuff I wasn't able to model, as far as like the exterior air cavity that's going to be required behind the the finished material. And then I'm showing my 5 inches of continuous rigid insulation on the walls to get me to roughly R25, I believe. I think that'll meet ASHRAE. Also on the roof, I've got 6 inches of polyiso. The numbers I found said that could get me to about R45. Eric seems to think that I'm way off there, and that's not going to happen. So I'm going to have to do some more digging there. I'm showing my 9-inch CLT floor decks, which seems rather thick, but I think that's going to be needed to achieve the spans that I've got. And then below that is my 4-inch cast in place concrete finish over the insulation that's required because we have the parking deck that's or the parking level that's uninsulated. So we have to find a way to insulate between the hollow core and the finished material. So I'm showing that there. And that's all I've got for that. That's pretty much it. If you want to take a look at the enlarged sheets that follow that presentation, the presentation sheets, maybe those more clearly indicate how the structure and everything works. But I'll shut up now and let you talk.
Thanks, Josh. Ash, I'll let you go ahead.
Okay, quick, very quick, Josh, I love the integration so much. I think you have the courage that I did not have when I was at your age, combining these two, because I was afraid of losing my A and a scholarship back then. I have just some concern, okay, regarding the precast and the wood over it. Precast transfer loads by gravity, and I'm not sure if in other way, if you had an earthquake, which is not the case here at all, and you shake this precast first 2 floors or so, they will shake. Okay, if you apply an earthquake to a site cast or cast in place frame, it won't shake. Probably it will have some cracks simply because of the rigid frame. So I'm more leaning, but we can discuss this later. We have positive discussions sessions in the past. We can discuss this later regarding the podium itself. And when I finish, please tell me why, for example, you preferred the precast over the site cast for your podium. Mechanical here are, I'm just, let me share here very quick. Mechanical systems here, very, very straightforward. Again, next step, as I mentioned to Paige, I would love to see the vertical, the vertical shaft and the ducts coming out and oh, I'm sorry, you using the packs. So I would need some supply and return in your corridors. Okay. However, in the first floor, probably it would be helpful as your final submission to give me some of the distribution in here in these zones. Zoning is fine. The CLT, you said you're using columns, and again for this 3 inches concrete topping, I'm not quietly sure. Have you looked at the article that I referred you to regarding this building that is made of a CLT. I think your 9 inches is enough here, Josh. If I'm not, unless, let's dig deep into this, unless we need this 3 inches stopping just to add weight, you know, to add weight a little bit to the structure. I'm with you again. It doesn't bother me that much, but we need to, it's a brand new system and really needs some digging. I love the arrays here and want to tell everybody that this is not the kilowatt, that's the capacity of the system, not just the consumption by these 25 to 50 residents. This 49 thing, that's your threshold between having 1 stair versus 2. So since you did 1 here, so your maximum capacity, and you have to prove it to the legislators, your maximum capacity will not exceed 49 people on this roof at its most. Elevations, I'm going to look sexy, very nice. I love them so much. Positives and negatives, and using different materials, shades and shadows. Glass placement is very successful. Just very last comment on the wall sections. The code here tells you 13 with wood construction for residential. That's R13 BAT plus 7.5 CI. I can't see anything here because, oh, you have it here. It's very hard to follow with these bigger dots here. So can you elaborate a little bit more on this very quick? I'm done.
Sure. Okay. I'm not using BAT, and I understand that diagram to the left shows that. But really, I just brought that in because I didn't have enough time to show everything that I wanted to show, so I just plopped that in there. But
you did the continuous.
Yes,
okay.
I did continuous on the outside, which is 5 inches of rigid, and I don't plan on using any BAT.
Okay. Well, BAT is not a sin in wood frame. Okay. BAT is a big sin because if you are using steel stud because of thermal bridging. But for me, if you really want to, this is your optimum one here. I wouldn't, the one on the left, I wouldn't beef up this with continuous insulation, Eric, unless you want to do so. You want to go for 189.1 high efficiency ASHRAE standards instead of 90.1 2013. So this would be high efficient building, which is fine for me. Again, I have no problem with that. But thanks for clarifying. It's so thick though. Okay.
Yeah. Well,
let's put it into place and then think about it, sleep on it, and see. Last thing, can you tell us why you preferred precast over site casts in this podium?
Yeah, I wanted to do precast because all the CLT panels are going to come already pre-assembled from the factory. So I figured that if I did that with my concrete beams, it's just the beams now. Well, it's the hollow core concrete deck is also technically precast as well. But the idea is modularization, so that everything can come to the site and be put together like Legos.
Okay.
Whereas the site cast has to have all the forms and everything and goes.
Okay, great, very great. Okay, can I suggest something? If you are looking for this kind of Lego thing, I love it. If you look at our new residential on campus, yeah, they do some mortars and stuff. The new residence halls at LTU campus, you can use steel in this case, and you can use these precast planks. That would be your Lego. I love this method, and University of Michigan has done it in their downtown Ann Arbor new grad housing. They use the